Okay, so we have to do in this problem three different things related to this integral here. So we're going to do them step by step, right? So first of all, we need to calculate this integral here, and for that, the change t equal to sine square of theta is suggested, right? So let's apply that, okay? If t is equal to that, then dt is equal to 2 times the sine of theta times the cosine of theta times d theta, right? And when t is equal to 0, then the sine square of theta is equal to 0, which means the sine is equal to 0. So the sine of theta, theta is equal to 0, right? Theta is equal to 0. And when t is equal to 1, then the sine square of theta is equal to 1, which means the sine is equal to 1, which implies theta is equal to pi over 2. All right, so we have these two limits of integration here. Okay, so the answer to this integral is, we can do this change of variable. So the integral of the arc sine of the square root of t dt is equal to the integral from 0 to pi half, right, in the new variable. Then if t is equal to sine squared, then the square root t is equal to the sine. In this interval, the sign is positive, so we won't worry about the sign. So this is the sine. So what we have here is the arc sine of the sine of theta, and then we have to multiply by 2 sine theta cosine theta, which is just the sine of 2 theta. All right, so we multiply by the sine of 2 theta d theta, right? Now this here is just theta, it's the arc sine of the sine, so it's theta. So what we have here is the integral from 0 to pi half of theta sine of 2 theta d theta. Okay, we can integrate this by parts, right? We consider this the derivative of a function, and that function is negative 1/2 cosine 2 theta, right? The derivative of this is equal to the sine. So this is equal to this, right? And that means that this is minus theta over 2 cosine 2 theta between 0 and pi half, minus, with this minus you have a plus, then 1/2, the integral from 0 to pi half, and then the derivative of theta, which is 1 times the cosine of 2 theta d theta. So this is integration by parts. Okay, now let's see, when theta is pi half, then we have the cosine of pi. The cosine of pi is -1, right? So we have -1 and -1 is +1, right? And then we have pi half here, so the first term we have is pi over 4. When theta is 0, well, this is whatever, it's actually 1, but it's multiplied by 0, so it's 0. So this first term here is just pi over 4. Then the second term, there is an easy primitive of this. It's just 1/2, the primitive of this is just 1/2 of the sine of 2 theta, right? So the derivative of this is that. So this is 1/4 the sine of 2 theta between 0 and pi half. Okay, when theta is 0, then we have the sine of 0, which is 0. And when theta is equal to pi over 2, then this is the sine of pi, which is also 0. So this term here is 0. All right. Okay, so the answer to this is just pi over 4. So the integral we want to calculate, this one here, is just pi over 4. Doing this change of variable. Okay, question B. Now we have this function, which is defined as two integrals, right, where the upper limit depends on x, okay? We have to prove that this is a constant. And the way to prove that something is a constant, some function is a constant, is to take the derivative and show that it's zero. So we calculate the derivative of this function, okay? And if you do that, the derivative is of this first term is the integrand substituted at this upper limit, which is the arcsine of the square root of the sine square, which is just the sine of x, okay, sine of x, multiplied by the derivative of this, which is 2 times the sine of sine of x cosine of x, okay? And then, well, we have to do the same with 0, but the derivative of 0 is 0, so you just, and the second term does not appear. We have to do the same thing here, so we have plus the primitive from, sorry, not the primitive, sorry, the integrand substituted at cosine square of x, but the square root of cosine square is just the cosine, so we have the arccosine of x of the arccosine, sorry, of the cosine of x. And now we have to multiply by this, derivative of this, which is minus 2 cosine sine, okay, because you have 2 times cosine because it's a power, and then you have to multiply by the derivative of the cosine, which is minus the sine, so you have this, right? This here is x, this here is x. By the way, it is important that we are in this interval here, because we have done in both cases the square root of sine square equal to the sine, and the square root of the cosine is equal to the cosine, or the cosine square, sorry, is equal to the cosine. And that is true because both the sine and cosine in this interval are positive numbers, right? So this is x, and this are equal. Oh, sorry, I wrote theta in this x. We have what I have to write here, x. Okay, so these two things are equal. Okay, so this is just 0. So within this interval, this function is a constant. All right, so what do we have to do now? Well, we have to calculate what is this constant, right? And that requires calculating the function f in some particular value. But a clever value to choose is one for which we know the answer, and we know this integral here. This integral is this one. So what we have to do is to choose an x such that this upper limit is equal to 1. And that is easy, it's just taking pi half, okay? So if we take pi half, the sine of pi half is 1, so the upper limit is 1. So we have this integral here, which we know the value of. It is pi over 4, right? And then for the second one, we have pi half here, but pi half here is the cosine of pi half is equal to 0. So what we have is just the integral from 0 to 0 of the arc cosine of square root t dt. And this integral is of course 0, right? Because the two limits are the same. So this is equal to pi over 4. So what we have is that this function is a constant and it's equal to pi over 4.